April 19th, Monday, Algebra 2 Honors. We will cover section 8.7, tangent function. So we are done sine function and cosine functions. We know how the transformation features would appear on equations and what else? And we studied how transformation would work on the graphs of each function. So now the third one, the tangent function, is today's main idea here. All right, now it's tangent identity related sine and cosine, okay? So I need you guys to recall how we can construct the whole information on the unit circle and all the exact values all around the critical points around the unit circle. And we were able to utilize a special right triangle appropriately to obtain the exact values or coordinates of each crucial point all over the circle. So for the unit circle, two things that you guys need to know is once you inscribe the right triangle that indicates the angle theta, then the hypotenuse of the inscribed right triangle is also the radius of the unit circle. So then in this case, the radius, at the same time, also the hypotenuse of the inscribed right triangle. And that's the key idea for us to obtain the exact value and coordinates, right? So the things around the unit circle regarding coordinates were this. So x coordinates related to cosine, because cosine ratio is adjacent over the hypotenuse and also the radius. And then in this case, that's 1, right? Then the denominator is 1, and we can verify the cosine exact value of the angle theta is also the adjacent side length, and that's also making the horizontal coordinate x. So they are all related. In same manner, when we talk about vertical coordinate, y, right? Then since sine ratio is opposite leg over hypotenuse, in which is the radius, and the denominator becomes 1, and that said, exact value of sine of the angle theta is also the vertical coordinate, the y coordinate at the point. So with all this, now we can conclude this. Then cosine exact value is the x coordinate and sine exact value is the y coordinate there. And radius slash hypotenuse is still the 1 unit. Then when we think about the tangent, we can conclude this. As you know, tangent ratio is the opposite leg of the right triangle over the adjacent. So then opposite leg is y value. Then adjacent leg is the x value. So instead of the ratio of opposite leg over adjacent leg, we can conclude that's also going to be y coordinate over x coordinate. And also we know y coordinate is the exact value of sine of the angle, and x coordinate is the exact value of cosine of the angle. And we can utilize all three all together, and our conclusion is this. So tangent identity is nothing but you can get the ratio out of sine over cosine. Or you can directly get the value by y-coordinate of the coordinate on the unit circle over x-coordinate. Okay, any questions? Okay, we can quickly recall what was happening. As we know, x-coordinate is the cosine, y-coordinate is the sine. Then, with the fact tangent ratio is the opposite leg over adjacent, and with all this right triangle inscribing inside of the unit circle, we can have the conclusion tangent is opposite leg over adjacent leg, also y-coordinate over x-coordinate, and also as the term of identity, it's going to be sine exact value over cosine exact value. So this is very essential and important matter regarding cosine, sine, tangent happening on the unit circle. Okay? And now, with this knowledge, we should be able to construct the graph of tangent as well. Okay? And remember, we had the slides for both of sine and cosine already. So now we recall x-coordinate and y-coordinate. And the x-coordinate is also cosine of the angle, and y-coordinate is sine of the angle, right? Then for the tangent, let's use x instead. So y is tangent x. We can still utilize the horizontal axis and vertical axis here. Now we know tangent of x is sine of the angle over cosine of the angle, right? So now, for example, if we get this angle theta there, then now all we have to do is we put 1/2 on top of the ratio and radical 3/2 on the bottom. Okay, then for the convenience and time for this instruction, I prepared this table here for you guys. So at 0, it's technically sine over cosine will get us 0/1, which is 0. And pi over 6, and you can calculate the approximation with your calculator. And if you have 1/2 divided by radical 3/2, so we can just do the first one here. So 1/2 divided by radical 3/2 is 1/2 multiplied by reciprocal. And then it's going to be 2/3. Then we cancel. Then it's 1/3. Then if you want to get the approximation of it and utilize your calculator and divide 1 by radical 3, and you should be able to get this approximation. And you go through all these critical points and you will get all this approximation, right? Then this is a little bit complicated, and then I prepared the next plotting with image. So if you plot all these images, plot all these coordinates, and it's gonna look like the image that appeared right now here. So when x is 0, the tangent x, the output is 0. And when x is pi over 6, and it's about a little bit higher than a half, and once you get pi over 4, and that's 1 unit high, and pi over 3 is plotted as 1.73. And as you see, as it gets closer to pi over 2, and it is supposed to go increase infinitely. So in that case, very similar to the characteristics that we studied for exponential function, we will have asymptotes around tangent function. Because as you observe, both sides, once you have the ratio changes, and then it's infinitely increasing or infinitely decreasing. And that gives you the situation that you can verify the asymptote there. For a tangent, both sides of this graph, right? And you should be able to recognize the asymptote. So then we can consider the image that we are currently looking at as the one repetition or tangent. So as you already experienced from sine and cosine, we're not gonna just remain within the first repetition, first period here, and you will see the all over the quadrant, and you can see it's repeatedly happening as this. So let me erase this. So do you see in the middle? You verify the very first period that we used to plot appearing in the middle. And every pi, why am I saying pi? Because you can consider one period from here is from -2, negative pi over 2, and positive pi over 2. If we consider this horizontal distance as one period, then it's total 2 halves of the pi, then it's 1 pi. So one period is, one period of tangent is pi here. Okay, as you see, what just happened on this slide includes a lot of comprehensive knowledge there. So if you were not really processing everything over moment, just like right now, it's totally fine. I'm recording it, and I will be able to upload this video this afternoon. So if you want to reprocess it and watch the video again. And also, I believe you guys already watched the UC Scout videos, and it was explained a little bit in that video as well. So either one, it helps you understand it better. And I strongly recommend you guys make sure you understand what is going on, how to construct the tangent graph, okay? And since we took a glimpse of how tangent graph would constructed here, and let's summarize what key features and what properties that we need to recognize this tangent here, tangent graph. Okay, so this is tangent graph. Then as you see, technically the domain could happening from negative infinity to positive infinity, but because of the asymptote aspect happening periodically, we have to have the discontinuity going on. So domain is all real number from negative infinity to positive infinity, but we have to exclude every time we have the odd multiples of pi over 2. Odd multiples of pi over 2 means, as you see the vertical asymptotes happening, the pi over 2 and 3 pi over 2, and the next one will be what? 5 pi over 2. Next one will be 7 pi over 2, right? And also the negative way, it's gonna go with negative pi over 2 and negative 3 pi over 2 and negative 5 pi over 2, negative 7 pi over 2, negative 9 pi over 2. That's the positions designated for asymptotes, right? Asymptotes. Okay, then what about range? Range, as you see, it's gonna cover from negative infinity to positive infinity. Vertically, this tangent graph is all continuous. And I don't know how many of you guys remember, but we studied the definition of odd function. Odd function is where the graph is reflected over the origin. And as you see, the origin 0, 0. Around there, you can see this graph is reflected over 0, 0, right? The diagonally. So we can consider tangent as an odd function. And as you see, this tangent function is also periodic. And what is the period of this tangent? Is a pi. And as you see, the first period can be verified from negative pi over 2 to positive pi over 2 if you just measure from the starting of the repetition and ending point of the repetition, and then it has to make pi long, okay? So then the period is pi. Then also the zeros. Zeros, which in other words and x-intercepts are 0, pi, 2 pi, 3 pi in positive way. And the left side of 0 will be negative pi, negative 2 pi, 3 pi. So every time it gives a pi, and you will see your tangent graph pass through the x-axis, and then that's the position designated for the zeros, okay? Then what else? Do we have any y-intercept? Yeah, so there's gonna be one y-intercept happening in the middle where it passes the origin, and only one y-intercept is 0, 0. Then also, we know tangent has a vertical asymptote, and the positions of vertical asymptotes happening is odd multiples of pi over 2. And as you see there, it's negative 3 pi over 2, negative pi over 2, and pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. Okay, so that's the key features that we are supposed to know about tangent function. Okay, and another thing. So now that was a graph, and now we will see how the structure of the equation of tangent function go. And very similar to either sine and cosine, we have tangent function equation with the a in front of the equation and b value positioned in front of the input x and c value that goes with all together inside of the parentheses and d value at the end. And how each features appeared on the equation affects the graph is exactly same way. So as you remember, the a in front of it is amplitude. And also one more thing that you need to remember is when a is negative, and also it's gonna affect the reflection of the graph as well, right? So reflection about x-axis when it's negative, right? And b value was affecting period. But in this case, what you need to know is the period will be not 2 pi over the value. For tangent, it's gonna be pi over the value. Why? Because the period of tangent is not 2 pi. Period of tangent is pi, and also b indicates how many repetition supposed to happen within one period. So for tangent, it's gonna be pi over the b value. And what about c and d? So c and d were translation, and especially c inside of parentheses were horizontal translation, and the d added or subtracted at the end separately was involving vertical translation. So here, what's obviously different from previous functions that we already studied, the sine and cosine, is the period is not 2 pi over b. This is pi over b. Then also, when you have b value is not 1, similar way, and we solve the expression that we get inside of the parentheses is the bx plus c, we take it out, set it up with 0, and we solve it for x, and that's going to indicate the phase shift, or in other words, horizontal shift. Okay, so this slide includes very crucial key features for you guys to recognize and then apply into your graph, right? So the A value and B value and C value and D value, they're very similar. I mean, it's the exactly same way that you can verify all the transformation from the equation there. But one thing that is very different from either sine or cosine is tangent period is pi. When you algebraically calculate the transformed period, it will be not 2 pi over b, For tangent, it's just pi over b. And base shift is still the same, okay? Okay, any questions so far before we start example? Oh, Chairone is asking, do we have to memorize the unit circle for the test? Ideally, students in Algebra 2 Honors, yeah, supposed to memorize everything on the unit circle. And because, as you see, if we were in all classroom instructions and we would not allow any calculators in even any unit circle reference sheets when we have tests. But I mean, realistically, we are, you know, like most of you guys remain in distance learning. And unless you are supposed to be in the classroom on the test day, right? Then, yeah, you guys have the reference sheets when you take the test for this year, I guess. Honestly, I don't have any control. Like I cannot just check everybody's situation when we take the test. But it will help you big time when you move on to the pre-cal if you have very deepened knowledge about unit circle. So it's not hurting for you guys to try to, you know, memorize all that. I mean, you're supposed to memorize all that, right? I hope that answers your question. Okay. Then Elizabeth's question is, what would a reflection over the y-axis look like on the tangent function equation? Could there be a reflection over the y-axis? Yeah. So reflection over x-axis is the a value in front of the equation is negative number, right? Then y, the reflection over y is the value goes in front of the x. So you might remember how we verify the horizontal reflection and vertical reflection, right? It's the same manner. So y reflection, so the horizontal reflection is you verify the b value being negative. Yeah. And a value being negative, and it's gonna be reflected over x-axis. So let's say the shape that we can anticipate is gonna be this. For example, the first period between negative pi over 2 and positive pi over 2 was like this. And then if there's vertical reflection going on, then it's gonna be like this. Because this one reflected up and then this one reflected down. Then what about horizontal reflection? So this one goes, this yellow one goes to the left and the bottom yellow one goes to the right. And then it's gonna be also the same here. Why is it happening? Because it's an odd function. Because we verify the original parent function was, it's the identical over the origin, right? So it's consequently, if there's no other transformation, it will become like technically the same. Yeah. Okay. That was a good question. Okay, then no more questions. Okay, then let's explore the example here. Example number 1. So this is one of the practice problem here in the unit circle. if the given angle theta is negative pi over 3, find the value of tangent of the angle negative pi over 3. So I picked this problem because this problem includes comprehensive multiple levels of knowledge, right? Okay, so then let's do step by step. So notice the given angle is negative pi over 3. Then we need to find the angle position on the unit circle first. So now I prepare the unit circle with the axis there. And then here, notice this angle is negative. Then from the initial side, where we can verify as 0 here, to be negative, we have to proceed on clockwise. From the 0, the initial side, we have to proceed clockwise. So pi over 3 in degrees, and we can multiply it by 180 over pi, and then we can cancel, and then it's 180 over 3, it's 60. But it's negative, then clockwise, for the negative angle, from the initial side, and it's 60 degree down. So then now I can see the terminal side must be around this position, right? So then let's notate this one as theta. Then now it's in the unit circle. We can utilize the right triangle with this terminal side being the hypotenuse of it, right? So then now I can construct the right triangle of the negative pi over 3 inscribed inside of the unit circle in that way. Then where is the right angle? It's right here. Then where is the angle given theta? It's right there. So it's theta. So that's negative pi over 3. And since we inscribed the right triangle there, and it's also the 60, and this is the special right triangle that keeps the ratio of all the legs at the same time. So the hypotenuse, which is the radius of the the unit circle, so now the hypotenuse is 1 here. Oh, hey, Kareem, can you hear me now?
Yeah.
Where did you go? I was like calling your name. Are you in the classroom today? You're supposed to be in my classroom.
Yeah, I called them on Friday, and what's it called? They told me, because I told them I wasn't coming, and then because I didn't fill out that I would be at school. I think they made a mistake.
So you're not officially in cohort A?
I mean, I might be, but I didn't choose to come back.
Wait, so you're so today you are at home?
Yep.
Okay, that's all I need to know. All right. Okay, so let's go back. And where was I? Okay, clockwise. And so the hypotenuse is also the radius of the unit circle. So we verify the length of the hypotenuse is 1, right? Then around that angle theta, the adjacent leg must be half. And then the opposite leg is supposed to be radical 3 over 2, but you have to be careful because it's below the x-axis. This is radical 3 over 2, but for our convenience, this is gonna be negative radical 3 over 2, right? And then positive 1/2 here. Does it make sense? Because the opposite leg is radical 3 over 2, but it's vertically negative position. So the vertical coordinate is negative radical 3 over 2. And the horizontal coordinate is still positive. It's right side of that 0, right? Okay, so with that, we can find tangent. So we know tangent of the angle is sine of the angle over cosine of the angle. And also we were supposed to get the value by y over x there, right? So then y coordinate is negative radical 3 over 2 all over x coordinate is 1/2. And then the next step, algebraically, we are multiplying the numerator and denominator. So negative radical 3 over 2 times reciprocal of the denominator, which is 2 over 1. And then we cancel the 2, and then it's going to be negative radical 3 over 1, which is radical 3 negative. That's it. And there's a couple more very similar format of the practice problem there. So once you understand all the steps that I just showed you, and you're supposed to do this, okay? You're supposed to be able to do this. Okay, then since we're almost to time, and let's move on to the example number 2. So if you are supposed to graph tangent of 5x, so this means no other features were transformed, but with the b value, this is b value of 5, then the period will be pi over 5. Then the length, the distance of period of this tangent will be shrunken into 1/5 of the original, 1/5 of the original. So compared to the original tangent here, compared to the original tangent parent function, and if you verify the labels in the x-axis, and then it's exactly 1/5 shrunken the proportionally in here, right? Okay. Oh, I guess I set the animation order incorrectly, then maybe it will just show all the way. But as you recognize, only transformation features from the equation is the b value, it's 5. And you can utilize, you divide the period of tangent pi by the b value of 5, and the result appearing on the graph is nothing but the period was shrunken horizontally 1/5 of the distance. And then you can see by all the labels compared to the original function, right? Then it should be appearing in that graph there. Okay, so tangent section was a lot. So I strongly recommend you guys to watch both of the videos uploaded on the modules, right? Over and over until you get all the steps understanding, and make sure you can do all 10 problems on practice just easily, okay? Okay, that's all for today.